Hi guys, welcome to session 1 for day 1. My name is Nita and I will be the moderator for this session. I would like to introduce the speaker for this session. Is Dean Langsam from SentinelOne. Hello Dan.
Hi.
Okay. Dan Langsam is a data scientist at SentinelOne, a rapidly growing cybersecurity AI company. He interested in data science, machine learning, deep learning, Python, scientific programming, data visualization, and Bayesian modeling. Specifically, he's a pandas enthusiast and maintainer of panda. Wow. Okay, in this session, Dan will deliver a talk about Clippy for Python, get heavy to Python internals to build a real-time code companion. Okay, for the participant, you can put your question on Hopin's platform because there will be moderators team to collect your questions. Okay, Dan, you can start now.
Okay. Hi, so I'm going to talk about personal code companion. If you remember the old Clippy character from the old Office software, like from the 90s, basically that's a character that tried to help you when you were inside Word, for example, to write better documents. That character is not remembered very fondly, but I think it had its advantages, and we can see how it can help us in Python. So let's start with a story. So this is me, I'm Dean, and this is Belle, my friend. We're both programmers, and we both love bird watching. And we went bird watching, and we started collecting timestamps, and at each timestamp we've seen a bird. We've taken down the name of the bird. So we had an ilang jawa, a hoopoe, a webtail, and on and on. And we put it inside a pandas data frame. So for those of you who is not sure what's a pandas data frame, it's basically kind of like an Excel for Python. You can create tables, which are called data frames, and then you can do operations on those data frame with Python. So our main goal was to take that table of data frames and turn it into this. A nice table that's nicely formatted. When each row is 1 hour, and at each hour I want to count how many of each type of birds did we see. So we have 4 types of birds for around 8 hours or 7 hours, and we want to get this result. This is the results. And Belle will take the mission first. Now Belle, she's smart, she's talented, she's hardworking. But the thing is, she misses something that I have. I'm not as smart, not as talented, not as hardworking. The thing is, I'm experienced with pandas, and that is going to be important. Why is it going to be important? Because Belle is coming to the task at hand, and she understands, well, I can do everything with Python and pandas. It's just going to take time, and maybe it's going to take some hours to do so. And then later, when Belle will return to her code in 2 months from now, she's going to see the entire left screen. That's a lot of code. That code is hard to maintain. So Belle is coming to me, and she asks me, hey, Dean, do you have something better that I can do to get the same results with pandas? And I said, oh, I remember that kind of task, and this is what I did. So instead of doing about around 15 lines of code with many things that are like moving parts, I have 5 lines of code that's very concise, very neat. And the thing is, those 2 screens are doing the same thing for the object that's called a data frame and gets us to the results. The thing is, on the right screen, it's a lot easier to maintain. Question is, why did Belle need me? Why can't we do something that will tell that when Belle is doing her part of the code on the left screen, there will be some helper that looks kind of like the Clippy character. And the Clippy character would say, hey, I see your grouping by the timestamp, so you can consider using the resample method. The thing with the resample method is that it's very good and it works perfectly. The thing is that many beginner users for pandas are not familiar with that kind of method. So why not let them know about it? And how would they know about it? If our helper sees that there's a column named hour, they know, oh, well, that's a timestamp maybe. Maybe I can suggest that to the user. So that's basically what we're gonna be doing in the next talk. A little bit about myself. I'm Dean. This is my, 9th PyCon talk, PyCon and PyData. I work for a company called SentinelOne. We're a cybersecurity company. We're doing machine learning to try and find threats for users. I'm also part of an organization called Data Hack. We organize hackathons and data for good events. And also I'm maintaining a package called dovpanda. Dovpanda is basically what you've just seen, but with many tips and hints to help you write better code. Today we're gonna see basically how to write like a mini engine of dovpanda. We're not gonna talk about dovpanda, maybe a bit in the end. We're gonna see how to write the engine of dovpanda. It's not a beginner's talk. It's kind of like an intermediate talk. We're gonna talk about some Python internals like the inspect module and the abstract syntax tree. But bear with me, it's gonna be fun. So the first thing to know is that in pandas, everything is an object. What do you mean by that? So in many other languages that maybe some of you studied before, Python is my first language. So for me, it's kind of like natural, but for people coming from other languages, this is not always the case. What do I mean by everything is an object? So let's say we have a function definition called my function. It basically gets x and returns x plus 5. Later on, inside our code, we can say that f equals my function. And then when we operate f on 5, 5 plus 5 is 10. So f of 5 is 10. That makes sense, just that you can take a function and put it inside a new variable name. The thing now is that you can say my function equals 1. So my function is no longer the definition of the function. And when you operate my function on 5, well, you see you get a type error because int is not callable. Question is, what do you get when you say f of 5? You get a 10. So basically, that's the functionality of Python. Everything is an object. We started with a function definition, called it something else, called the function, we put a different value in it, we have assigned another value to it, but the other behavior, the other function called f stays. The thing you should do with it is to handle this with care, because even if you taken like internal names for Python, let's say the function len, we say it equals to 5, Python will let us do it. And then later, when we ask for the len of Indonesia, we'll get a type error. We no longer have the len function inside the Python language until we restart the kernel. What we're going to try to see how we can do is how to hook a function. What's hooking a function? Basically, if you write your own code, you can create kind of like a mechanism that's running functions, but gives the user basically like placeholders, like that says before running the function, and then the user can give a function for us. That's very popular in web, for example, but also there's packages that are doing this in Python. The thing is, we're trying to hook over every function. Pandas is not letting us do it from in the basics, or most packages are not letting us do it. But we're going to see how we can leverage Python's internal mechanisms to actually do it for everything. So basically, I can save the function len into a new name. We'll call it original len, right? The same as we did f equals my function, we can say that len is equal to original len. Now we can define another len, other len, and it gets an object, and then it prints something. It says len works on lists and strings, will not work on ints and floats. And then it returns the original len, right? Because the original len is now doing the same operation as the len. But now we can say len is equal to other len. So basically we overridden the len function, but there is something else called original len that's basically doing the same as what we expect of len. What does it do? So now we can say what's the len of PyCon, and you can see. So that's the first hooking function. You can see that len works on lists and strings, will not work on ints and floats, and then it does not interrupt the user with continuing to work as they expect. You still get a 5. And when you say what's the len of 5, well, will not work on ints and floats. It says, and you do get a type error, so that's the expected behavior of len. Another example, let's attach hook on the cosine function from the math module. So we import the cosine and pi. We again take the original cosine, assign it to the cosine, write some message in another cosine, and then we take the cos, and it equals to the other cosine. We check, we see the cosine of pi. You get this kind of message, cos works in radians, not degrees, and it gives us the answer, which is -1. So now I'm working. Again, I've done this thing. I've hooked over the original cosine, and now I'm writing many more lines of code. Maybe I've got some code from other people. So many minutes and lines of code later. Again, in my code, this is the same code as before, just, I don't know, 200 lines down. I say, oh, I want to hook over original cosine. So I'm doing this again. I'm doing original cosine equals cosine. I'm defining another cosine function that gets another message that says cosine is a flow between -1 and 1. I'm doing basically the same, and now I'm running cosine of pi, and this is what I get. I get the message that I wanted, and then like a million times the message that I've done before. So that's weird, right? And when you think about it, it's not, because we did this. So we said original cosine equals cosine, but cosine itself is not anymore the original cosine, it's the other cosine, and then it's doing this many times, and eventually we get recursion error. So it could have run infinite amount of time, just Python protects us from that, and it gets us to recursion error, and the maximum recursion depth exceeded reached. So what can we do? We can try and keep a ledger. So basically, I as a programmer can say keep a ledger and say check every time. Now I want to hook over a cosine. So do I check, did I hook on the cosine? And I see the ledger, I see, oh, yeah, I did it. So I'll use the original definition of the cosine that I've already used. And then I can ask, oh, did I hook on sine? And now I see that, oh, I did not hook on sine. So basically I can say, okay, let's take this function, put it inside the ledger to always keep it handy when I need to hook over sine again. How does it look in actual Python? So you can say from math import cosine and sine, and then we can keep a ledger. The ledger is basically a dictionary. Why are we going to keep a dictionary? Because now we can we can try to make 100 hooks over the same function. We're always going to come back to the definition of the cosine from the ledger, from the dictionary. We can see that the ledger has strings as keys, and then the values are functions, basically like the blueprint of the function. So now we can, as long as we keep ledger safe, we always have the definitions of the functions that we kind of overridden. So they're always in a safekeeping somewhere. So we can take a function, and basically when we look for a function name, it will go to the ledger and give us back that function. So when you say the original func of cosines, the string cos, you get the built-in function cosine. Okay, so now Belle is trying to write a code that she gets the original cosine. She's doing the thing with the message she wants to hook and tell the other users, and it works. And then I come to the task at hand, 200 lines of code later in the same file, and I'm getting the original cosine. I'm defining that, and I can see that it works. Where there is no Gaussian error. It's okay if I didn't know that Belle already did this. I'm just adding my own functionality. So what can we do now? So now basically I need to take every function from the math module and put it inside the ledger. So now I know, okay, if I'm building a ledger for the math module, all I need to do is write all the functions and methods in the math module. And that's it. Now, even if the user kind of destroys the functions in the math module, that's fine. They can always access the original ones from the ledger. The thing is, and I'm sure you're asking yourself, is why should the user do that? Basically, it's manual. So maybe the math module has, I don't know, hundreds of functions. It's bloating the code, right? Because I need to define the ledger, and each function is a new line. We may not use all the functions. Maybe I'm importing the cosine function, and I don't even need the floor and the factorial and the combinatorial and everything in there. And it also requires foresight. I need to know, oh, the users are gonna they're gonna want to override the fabs, but I don't know, maybe they don't. So why should I start and think about all those things? What should I do? Maybe I have some way that when the user tries to hook over some function, only there and then would I go to the ledger. I will ask it, does the key exist in the ledger? And if not, only then write it. The challenge with that is that when I want the cosine function, how can I get the string that says cosine, right? It's kind of like you can't call the string cosine. For this, we have in Python two great functions, getAttribute and setAttribute. Basically, getAttribute is our way to get functions using strings. Where can we see that? Let's say we want to ask a user to run some function, and the user writes it maybe in an input box, or maybe they call it from a CLI, and we get a string called cosine. So you can say in the third line, my cosine, that's for example, is equal to getAttribute from where the math module get something that's called cosine. So once we did that, it's the same as saying my cosine equals the function cosine. That's basically a way to access functions and methods from objects, from any objects. It can be a class, and it also can be an entire module, because everything in pandas in Python is an object. So you do this, and then you can ask what's the my cosine on my pi, and the answer is -1. The same things go with the setAttribute. So you can basically import math, and then setAttribute of math, another value that's called almost pi. It equals to 3.14. And when we ask for math.almost pi, we get the answer 3.14. That's I think not very intuitive, right? We've taken math, which is a built-in module of Python, and we're just writing new things to it. That's almost not fair. Like we're actually overriding Python itself, but we can do that. Why is it good for us? We can import math, and then we can start with a blank ledger. It's just a blank dictionary, and now I can ask for a function, for some name of the original function. And now we can ask if the name is not in the keys of the dictionary, put it inside it. So the ledger in the place of the key, get attribute, get the function from math that's called the name of the function. For example, now I'm trying to override or hook over a function called ceiling. So I'm basically requesting back the original ceil. We get a function, the built-in function ceil, but now when we check the status of the ledger, we can see that we've added a new key value pair into the ledger, the string ceil and the function ceil itself. So now we can write a function that's, we have a function name, that's ceil. We can write hook for ceil. So that's what we called before other func. So hook for ceil, it will print something like print ceil except float, but returns ints. That's a good helping function for people who are new to this function. Now we can say that the original function is the function, access it through the ledger using the helper function that we've written. And the hook function is hook for ceil. Why is it good for us? Because now we can define other func. It gets args and quargs. Before we've got an object because we knew it's going to be just one thing that we're going to operate on. But in reality, we're going to try to hook over any function. So we're getting args and quargs, and basically what other func is doing is, first of all, run hook function. So now you can see that it's not just print. Basically in hook function, we're going to see later how inside hook function we can basically access everything. We can do everything. Like we don't need to write. We can do some logic, ask some if statements, stuff like that. And after you've run hook function, we can return the original. I'm sorry. Wait just a minute. See if the audio works. I hope you can now hear me better. I'm sorry about that. Okay, let's continue. Okay. Now, the only thing left to do is to say, before we said that cosine equals original cosine, now we can use the set attribute function. We're setting the attribute of the math module. We're setting func name to it. Func name was ceil. And then what's the new value? That would be other func. So it's basically going to run hook function and then return the original. Let's check this out. So we're trying to run math.ceil of 4.5. It gives us the message, ceil accepts floats, but returns ints. And then it returns 5, which is the expected functionality of math.ceil. Okay, so that's like the end of the first chapter. Now we're going to see how we're going to make it better, because we've seen that we have some kind of function that expects another function. And in Python, we have a cool functionality that's called decorators. That's a way to work with functions that accept functions. What do I mean by that? Let's start with an easy example, and later we're going to go back to our task at hand. So let's say I have a function that's called add. It gets x and y, and basically it returns x plus y. Now I have another function. That function accepts a function, any function, for example, add, but it can accept any other function. And inside it, it defines an inner function that gets x and y. Sorry about that. And it prints the values of x and y, and later it runs the function that it received. Right, so let's check it out. Let's say f equals print args of add, right? Because print args receives a function. And then we run f of 2 and 4, and it's basically the add function with the extra functionality. F of 2 and 4 first prints x is equal to 2 and y is equal to 4. and then it returns 6, which is the expected functionality. But then I remember, okay, everything in Python is an object, right? So instead of saying f equals to print args of ed, we can say ed is equal to print args of ed. And now when the user is trying to use ed, it comes out automatically out of the box without defining anything new. This is now how ed works. It's basically said x is equal to something, y is equal to something, and returns the answer. The thing is that this pattern, that's f equals to a wrapper of f, is a very common pattern in Python, and the developers made something that's called a decorator for us. So instead of doing a function that accepts a function, then doing another function, then saying ed equals print args of ed, we can put a decorator. We say at print args, and then the functions that it will get. So let's say we define another function called sub of x and y. And now when we say sub of 10 and 7, we first print the values of x and the value of y, and eventually it returns the result. Why is it good for us? Because basically we've done the same thing, right? We have an original function, that's in the first line. Then we have an hook function. Then we have a function that's doing something on functions, and then it sets other functions. So instead of writing this, we can write this. We can define a function that's called addHook, and it gets a function name, let's say the string cosine. And the first thing it does is it's looking for the ledger, and it expects back the original function from the ledger. And if it doesn't have it, it adds it to the ledger that's outside of the function. Now we define other function that gets the hooking function. So the functions that we've already written, let's say hook for seal. And what is it going to do? It also has another function in it that runs the hook function, runs the original, sets the original on the hook function on top of the original, and then returns it. So this takes a minute to actually understand, and I encourage you to actually go read about decorators. But the thing is that now we can do this. We can say at addHook on which function? The function floor. Now we define a function. We call it hook for floor. We can call it any name. It doesn't matter. The thing that matters is that in 3 lines of code, we've done the same things as we did before, because now math.floor of -4.2, we get a message. Floor and a negative number may be confusing, and indeed it returns -5, which is confusing because it's not -4. And we hooked over a function in 2 lines of code. Imagine we're going to later look at use cases, but I just want you to imagine, like, if you have some code that you've written before and you don't want to change the code, but you want to help user, maybe to add some extra layers of documentations or stuff like that, you can hook over the function that you've already written and add messages that explain new users how to work with them. And that's going to be easy because now you don't even have to think about, oh, do I need to access the ledger? I need to keep the original versions and stuff like that. The only thing you need to do is add hook, tell it which function do I want to hook upon, and just let the new function that runs before the original function do anything. So basically, we're done. Now we're going to see how we're going to make this better, but this is what you need to do. You've written your own Clippy for Python, Clippy for any Python package. Now we're going to speak about something called inspect. Inspect is a library inside Python that's basically trying to look at Python code and inspects it. So basically, Python, we're using Python to access the internals of Python. That's very fun things to do. When I started programming, like around 4 or 5 years ago, I felt that programming is superpowers, but then you kind of get used to those superpowers. And when I found out about inspect, about the
abstract syntax tree around a year ago, then you get again the new feeling of superpowers, because you don't only you not doing just like anything you want with code. You take the code to change the Python itself. That's amazing, I think. Why are we going to try to use the inspect module? Because now when we're going to get the original function, I don't want to just write one message. I want to maybe have some logic to it. Maybe if the user entered cosine of minus pi, that's fine. Just let the user have it. But if the user entered cosine of 180, then I think, oh, maybe the user think cosine works in degrees, not radians, and only then will I give them the message that says cosine works in radians, not degrees. So let's have an example. The example to the left, the right args that we did before. Now instead of taking only x and y, we'll receive args and quargs. And it will first print args, then print quarks, and then return the function as before. We say write args of add. Now add is not just x and y, it's x and y and z, but z also have some default value. It returns x plus y plus z. And we see when you say add 1, 2, 3, we print the args which are 1, 2, 3, the quarks are nothing, and then we get the expected answer of 6. But when we say add 1, 2, and z equals 3, well, now z is a keyword argument, and it's inside quarks, and it prints something that's different. And also when we add 1 and 2, z goes to a default behavior, but when printing args and quarks, we don't see that even. Why is that? Because Python is not looking at this, it will only look at the defaults later. So now if I want to take a hook function that takes the value of z, well, not in all versions I will have z. And even then, I'm not sure if I got z as the third argument in the args, or maybe I got it through z equals through some dictionary called quarks. What can we do? We import inspect, that's a built-in library, and we take the signature of the function that we've written, add, and then we can bind to it values. So let's say we bind 1, 2, 3. We can look at the signature. We get some bound arguments class, but the thing is with the class is that you can take you can ask for the arguments as a dict, and it says we get key value pairs of x, y, and z. Why is it good for us? Because then we can again do the same thing, that inspect the signature of add, but now we bind 1, 2, and z equals 3. But when we ask for the dictionary of sig.arguments, we get the same dictionary. And then again, for the first example, for the third example, we bind only 1 and 2 and accept to get the defaults, and we see, oh, we only got x and y, but that's fine because the inspect module has another method that's called apply defaults. So I call the signature of apply defaults. It goes back to Python, see, okay, z equals 3, fine. I can put it inside signature.arguments, and then I get the same dictionary with key value pairs. Why is this good for us, right? Because it's kind of becoming convoluted, but we're not sure for why should we do it. We can now take the inner function. We can inspect the original function that we already kept in the ledger. We can bind the args and the arguments and the quarks. We can apply the defaults, get the dict, the args dict, and then in the hook function, we can pass on the args dict. But you ask yourself, why? Why should I do all this code? What's in it for me? And the thing is that now you can try and help the user with some interesting logic. So let's say I can head hook on power, and we get the args dict. And now what pow does is basically doing x to the power of y. So if the user is doing, I don't know, 2 to the power of 4, I just want to give the user back 16. That's the answer, and I understand, okay, the user needs to do 2 to the power of 4. I will not bother them with my messages. But if the user is doing 4 to the power of a half, Well, why should they do that? They could just take the square root, right? And so I print a message: taking a fractional power is like taking the inverse root. But also, if the user is getting x as the base of the power and it's less than 0, well, if we do something that's less than 0 to the power of some fractional thing, this could be an error because it's not defined in math, not related to Python. You can't do the square root of -4. Let's see how it works. math.power of 2 to the power of 4, that's 16. I'm not bothering the users. But now the user is asking for math.power 16 of a half, and then the Python, like our function, but basically Python, the user will on the screen see a message: taking the fractional power is like taking the inverse root. And then the user says, okay, I want now -4 to the power of 0.5. And you can see that the user got value error from Python. Python says it. Python says math domain error, but that's not very meaningful to the user who's done it, right? Like they say, okay, what do I get from this message? I'm not sure what's math domain error. But luckily, the user does use our helper package. And the helper package says, okay, notice that taking a fractional power is like taking the inverse root. And also the base is less than 0. It may not work for fractional powers. Now this is a more meaningful message. The user can copy paste that into Google and understand what's happening behind the scenes. Let's look at the abstract syntax tree. We're going to do this to help us understand what did the user mean when calling the original function. So first of all, let's see how Python thinks. Python basically, when it sees a line of code, it turns it into a dictionary. Let's say we have x equals 4. You can see the red squares to the left and to the right in the code and in the chart. Basically, x equals 4 is a module. And first of all, Python looks and see the equals sign, that's the body, and it understands, okay, this is an assign statement. Now, which parts the assign statement has? It has targets and value. So the targets are x here with ID that's called x, and then the value is 4 with n equals 4. It's some value with the value of 4. So it's a value with the value. And then eventually it gets to the line end and it says, okay, store this. Store 4 inside x. And if we have 2 lines, you get basically a more complex tree. So the first line is this, and the second line is this. And you can visualize any Python code with this website that's on top. So we can do this on ourselves. So we can import AST. We say ast.parse the line of code, and we can see that the node body 0, it's exactly the same things that we can see in the chart. It's an assign object, and it has a body. The body has targets, and the body has values. And you get a constant object, a name object, and an assign object. That's basically how Python thinks. We're going to now see why is it good for us. So let's go back a bit for pandas. Pandas, on top of being something like an Excel, it also has something that's like a list. It's called the series. The series is like a list, but it also has an index. So you can see that we can define a series of pandas with 1, 3, 2. And then we can call something that's called sort values. And you can see it on the left, it's the index. The index is, let's leave it for now. It's basically the original locations. But you can see that we call sort values, we get 1, 2, 3. But then we call S again, and we can see that the operation was operated on S, but it didn't operate on the object itself. It just did it once and then returned the values, but S itself didn't change because when we call S, it gets 1, 3, 2. Python has something that's called in place equals true. And when I say in place equals true, it actually changes S itself. But the flaky things about it is that you get, it returns none. So it changes the object, but returns none. And when you print S, you get none. And that's not a good thing. So now we can say, okay, let's add hook on sort values that's doing this. we're basically getting the line of code. So in the first lines, I will not go over through it, but that's basically how we get a string of the code that called the stored values. And then we can understand if the node, basically the part containing the code, if it is an assign object, because if it wasn't, the AST would say this is an expression object or this is a for object and stuff like that. So if it's an assigned object and also the user called in place equals true, then we print careful, you're assigning none. Now we can see that s is equals to 1423. When we call s equals s dot sort values, it doesn't say anything, but when we say in place equals true, it returns, like it says, be careful of. I'll just finish with the motivation. So I've built dovpanda. If you use pandas, I encourage you to use it. Basically, it's doing this, but with helpful tips for pandas. You can see that if you group by the hour, dovpanda is returning those examples, those warning messages. Also, because this is a function, we can hook on top of it with on a Jupyter notebook. So now you get a nicely formatted warning messages. So I encourage you to use dovpandas. More functionality. Someone else could be dov-sklearn, dov-torch, etc., etc. You can use it to get a wiki layer of your team. So this is the new guy on the team. We'll tell him, okay, maybe try to write a function that's like a complex logic, but that logic is very complex and we can't write it inside the docstring of the function. So we hook on top of it with an helper function. I'm sorry, I'm running. I say we're close to the finish line. And this basically, we're gonna tell the new guy, oh, I see you didn't use the function correctly. Maybe go to the team wiki and understand how this works. We can also do white hat security. So we can see, oh, the user is trying to create a MySQL engine, but with I'm sorry about this is my baby who just woke up. This is what you get when you get virtual conferences. So we create an engine and we see there's password inside the string, so it warns the user, hey, pay attention, you provided a database string containing password, do not push this into the repos. We can also do this with a Contextmanager and just do like a hook. This is me. I encourage you to look at my profile, and if you have any questions, if we have the time, this is the time.
Okay. Thank you, Dan, for your amazing talks, but we're running out of time. So maybe you can show your contact on your profile again. So the participant can see your contact. Okay. So guys, because it's the session is finished. No Q&A here for this time, but you can ask Dan, reach out by his profile, Facebook, or maybe LinkedIn. Thank you for your amazing thoughts.
Sure.
I hope we can meet again in next time.
I hope so. Maybe in real,
Okay.
in person. Thank you.
Yeah. Yeah, thank you. Thank you, guys. Okay, for everyone, thank you for watching this session. You can go to main stage for the next session. Thank you. Thank you from me and moderators team at backstage. Thank you.